Okay, I'm going to talk about the first package, MLR3. So this is the base package. We have, I don't know, something like 20 packages now. I will give an overview of the packages at the end of my talk here. So we are now just talking about the base infrastructure package here. So why do you want to use a package for machine learning R? As you might know that R already has many packages for machine learning. For example, there are packages for random forests, for SVMs, all stuff of things, right? And the main problem is that you don't have a unified interface for these. So if you want to do something like a benchmark, you want to find out which learner works best on the data set, you have to do something like a benchmark, you have to do a performance comparison, right? And if you do this without an extra package like MLR or MLR3, you would start writing something like this. For example, you want to try how well an SVM works, then you take the E1071 package, for example. There's an SVM implemented here, and this implementation supports a formula interface. So if you want to fit SVM with the iris data, you have to say, hey, this is a column where I want to predict labels for and use everything else as features, right? And then you get back something like a model here for the SVM. On the other hand, if you want to do something like gradient boosting, here from the extreme gradient boosting package, there's no formula interface supported. So you have to first split the data into a numerical matrix here. And then you have to provide the target column, the labels as vector here. And yeah, so two packages, two different interfaces. And if you want to compare something like 10 learners, it's often like 10 different interfaces. And so you're writing boilerplate code. And this quickly piles up to hundreds or even 1,000 lines of code. Yeah, there are other packages which has the same goal, like MLR3. You might know the predecessor MLR. So same guys. So we are also the developers of MLR, and this is the successor here, the MLR3 package. And there's also Carrot or Tidy models now. But all have this intention to solve this problem here, to make performance comparisons and benchmarking more convenient. So what's in MLR3? We have objects for all machine learning stuff. For tasks, we have objects for learners and for measures and so on. And this enables you to do performance evaluation and performance comparisons in an easy and convenient way. Before we jump into machine learning, I have to quickly introduce you to R6 if you don't know it yet. R6 is the class system we use internally, and not only internally, you have to work with these kind of objects if you want to use MLR3. And so you need something like a brief introduction. It's not too hard, right? R6 objects can be constructed by calling the class name and then the constructor new, right? For example, if you want to create a classification task, you call the object task classif and then the constructor new, and then you can pass some arguments here. For example, the ID, the data frame of data, and what's the target column. What you get back is an instance of this class, an instance of task classif object. These objects have fields which you can access, which just hold information about the object. For example, you can ask the task, how many rows do you have? Right, by just accessing the field n row. And the return value is here, integer 150. Objects may also have methods. So it's not just like a list. There can also be functions in there. So the task object also has a filter method. And you can say, hey, filter the task so that only the first 10 rows are kept, right? And everything else is discarded. And what's special about a R6 object is that if you do this operation here, you mutate the object in place. So this is something you might know from environments in R. This is also called reference semantics in other languages. So after calling the filter method here, and you don't have to assign this to the object task again. Just by calling this, you change the object task here. So if you again ask how many rows do you have, it's only 10 now. Yeah? This is something many people are not used to in R. But this is basically what environments are also doing in R. There's another thing, there are so-called active bindings, which are supported. So these fields can be just a value or an object itself, an R object, but you can also use a function, which is then called automatically. For example, if you say the field nrow, which is actually an active binding, when you assign something, you get an error here. So because we have a function which is in code, we have a function internally which is in code which says, hey, you can't set this field, it's not allowed. Right? So we can also use this a lot for something like argument checking. So if you have a task here, and task can have properties, and you can't assign null, so it's not allowed, but it would be allowed to assign some random characters here. So not that important to work with MLR, so you don't need to completely understand this, but we are talking a lot about active bindings later, so that you have an impression what we are meaning with this. So this is basically just like a field, but internally function is called. This can have side effects. Sorry. Okay, and this is all for R6 for now. Back to MLR3. When we started developing MLR3, we wrote down some stuff which we find important and what we have learned from the predecessor MLR. So the previous package MLR used S3 as class system, and yeah, we felt kind of limited with this approach. So we really wanted to do object orientation, and so we switched to R6. This was the first thing we wanted to really accomplish. Second, we wanted to use data table more because, well, it's pretty fast. And we also liked that it has reference semantics and that you can place complex objects in the fields. So it's also possible with data frames, to be fair, but not that well supported for printing and so. And this allowed us to work with the data structures in a more efficient way. And third, we wanted to be light on dependencies. So these are our external dependencies. So we used R6, data table, logging package, this to create unique identifiers, some data sets in here, and digest for cryptographic hashes. And that's it. And all these packages don't have any more reverse dependencies or recursive dependencies here. And there's some more packages in the description file, but these are all developed by ourselves, so we don't count them here. So yeah, now moving slowly to machine learning again. We usually start with a tabular data for the most problems, right? And this is what is supported by now in MLR3. And we say that we have some columns which are called the features, right? And one column, or for survival, maybe two columns, which are the target, for example, for classifications, the labels we want to predict, or for regression, the outcome we want to predict. So the target column basically determines the type of task. If it's continuous, then you have a regression task. If it is a factor variable or discrete, we have a classification task, right? And for example, the iris data set, right? Here is the target column. This would be a classification task. And these would be the features here. And this is what we call the target. And for construction, we've already seen this. We call the task classifier object and the constructor of it with an ID, the data frame, and the name of the column we want to use as target column. And we get back an instance of the class task classifier. If you print the task, get a nice overview here, for example, the dimensions, the target, what properties the task have, and what kind of features are in there. And you can access certain things of these objects. For example, you can access the dimensions here again, the feature names, the target names. You can query the data. You can subset or filter the task, and you can also expand it, combine columns or rows. And there's much more, but the more technical stuff is in the manual page. One last insertion here. So this is kind of bulky and lengthy, calling these constructors. So we have something, we use dictionaries for all the objects that MLR provides for you. And so we have some dictionaries where we store, for example, tasks we use in use cases or in examples a lot. And you can, for example, in MLR tasks, the IBIS dataset is in there, 5 to 6 more other tasks, and you can get the task out of the dictionary with this short form function here. This is for task, this is for learner, measure, resampling. And another advantage is that these dictionaries can be populated by their own packages. So if you load the MLR learners package, this dictionary, MLR learners, will be populated with, I don't know, 20 more learners, right? And if you load the survival package, this dictionary now holds survival learners. So this is yeah, basically what you have to remember. These short forms we'll be using a lot in the next slides. So you can, for example, here query what's in there if you don't provide any argument for this short form function here. And you see, oh, Boston housing dataset is there, breast cancer, and so on. And if you want to have a single object out of the dictionary, you provide the ID here, for example, to get an instance of the classification IBIS task. You just call the task function here with the IBIS a string, and you get back the object. Okay, and you can also convert it to a data table. You can basically do this for all objects, which are implemented in the package. So we love these tabular representations. So for example, you can here convert the implemented learners to a data table, and then you can start subsetting it, for example, for predict type or stuff like this, many more columns here. Okay, so we are tasks now. The next important thing is data. We want to learn something, so we need learning algorithms. So this is basically what learning algorithms do. They are two-stage. There's a training step and a predict step. And in the training step, you provide the learner some data set, right? This is what we call the training data. And then the learner learns something about the data. It learns the parameters, its coefficients, right? And stores something internally, what we call the model. And then if we have another tabular data structure, we call the test data, we can provide it to the learner. What we get from the learner now, based on the learned model, is a prediction. So this is the estimate for the target variable, right? To construct a learner, we use this short form here, LRN for learner, and say we want to have a classification tree from the rpart package here. The learner has this ID, class.rpart, and then we can just train it, right? So we have an object of type learner here. We call the train method, provide a task. The learner will update itself, stores the model internally, and we can also access the model, right? By accessing the field $model, and what's in here is the model as learned by or as returned by the rpart function. So if we want, we can now exit mlr3 and call plot on this object here or something else. I don't know, summary, whatever. Learners have hyperparameters. For example, this is the data table of hyperparameters for the decision tree. We have stored information about these hyperparameters, the ID, the type, lower and upper bound, allowed levels, and so on, right? There's a little bit more in here. This is really handy if you want to start tuning these learners, or if you just want to look something up, which is the allowed feasible range or something like this. You can do this by querying the learner directly. Okay, so you have these hyperparameters in there, and you can also set the hyperparameters for a learner by just assigning a named list to the field values of the field parameter set here. And then here, for example, we say the maximum depth for the classification tree is now 1. And if we train the learner again, well, it will behave differently, right? It will give a smaller decision tree here, for example, decision tree of depth 1. So this is just a stump. This is really, really shallow tree. Just one split point, right? Yeah. And then to get a prediction out of the learner, you have to provide a data set. Again, for predictions, the test data. Here, we have something which is called new data. There are 2 rows in there and values for all features, right? And we then can call the method predict new data of the learner on the new data frame, or the new data frame. And what we get back is a prediction object, right? And as you can already see here, this is kind of tabular. We have stored the row ID, we have stored the true value or true response, which is an A here because, well, it's not in the data, so we don't know it, but we could have opted to also provide it here. Then we would have also stored it in the prediction. And here we have the predicted label from the decision tree for the first column, for first row and second row. Yeah. We can also say that the learner should predict not only the labels but also probabilities. So to do this, we just set the field predict type to prop for probabilities, and then if we call the predict new data method again from the learner, we again get a prediction object, but now we have additional information in here. So not only the row ID, the truth and the response, but also probability for class Setosa, class Versicolor, and class Virginica. So for example, the decision tree is perfectly sure that the first row is Setosa, and don't know if it's Versicolor or Virginica. It's 50-50 for the second row. So yeah, it's just sampled, I guess, the label here. So closer look at the prediction object. You can again use as data table to get a tabular representation of the data which is stored inside. And there are also these fields or active bindings where you can access some of the data directly, for example, the response by just $response here. And there's some more stuff which you can look up in the manual page. So now we have trained the learner and got a prediction. Now it's time to score the prediction to measure how well the learner performed on the data set. So this is what is called performance evaluation here. We now have here a learner which is already trained, so there's already a model in there, and we have some new data here. And we start by splitting the new data or the test data into features and target. The features go into the learner, and the learner gives us a prediction, right? And the true column, or the target column, so the ground truth also called, we then compare with the prediction here using a measure. So this could be, for example, quadratic loss or something like this. And what we get out here is a single number, which, yeah, just depending on the measure, is low if predictions are really good, and high if not, just guessing or so, or the other way around, depending on the measure. So just a comparison here with these two vectors, just a function which gives us, depending on these two vectors, a number. To do this in MLR3, we first create a task where we also have the target column in here. We could also do this with the data frame. We don't necessarily need a task to do this, but here it's done with the task on the slides. So we have a learner, and we call predict instead of predict new data, because we're now providing a task on the task here, and what we now get is a prediction with the truth column here, not NA, but actual values here. And then we can call the score method of the predict object and provide a measure. Here's a classification error, and what we get back is the number says, hey, you have scored half of the predictions correctly and the other half incorrectly. Right? So just just counting how many are incorrect, basically, and then dividing by the number of objects in the prediction.